Hi guys, so this video is about limiting and excess reagents and how to calculate them. First of all, we are going to understand what is meant by an excess or a limiting reagent. So for example, if you have 8 slices of bread versus 1 jar of peanut butter, it is the slices of bread that will determine how many sandwiches you could make. And then the peanut butter jar is going to be in excess and left over. Similarly, in reactions, we have the same concept. And so sometimes if you have an insufficient amount of one of the reactants, what does that mean for us? In the sense of limiting reactants, they are basically substances that get used up first. They stop the reaction, therefore, whenever they're used up, and they limit the amount of product that is produced. It's very important, therefore, to write this reaction in an equation in order to determine which one is the limiting and which one is the excess. So here are the steps that we're going to follow. So first of all, we're going to write the balanced equation for the question. So we have to read the question very well. So here, for example, it says, find the limiting reagent when 1.22 grams of oxygen reacts with 1.05 grams of hydrogen to produce H2O. The first thing you want to do is you want to write your balanced equation. Your balanced equation would be O2 plus H2 gives H2O. Now, you have to balance because you need to balance because you need things to be in stoichiometric amounts, meaning correct amounts. So for your mole ratio. So for example, you have 2 oxygens, but you have to balance your oxygens here. So you put a 2, but then that means you need another 2 here for the hydrogen. So this is a gas, and then water vapor, and then it gets converted to liquid as it condenses. Okay, with energy. This is a combustion reaction. Now, convert the given actual masses of both reagents to actual moles. So that's the next step. So we're going to take the mass that is given actually in the experiment for oxygen, which is 1.22 grams, okay? And then the other mass of hydrogen is 1.05 grams. It's very important to know which is which. That's why I'm writing them underneath each other. And then I'm going to convert them to moles. So moles is equal to M divided by the molar mass. So for oxygen, it's 16. So 2 times 16 because I have 2 oxygen atoms. And then here for the hydrogen, it's going to be 2 times 1. And then I'm going to add my units here, gram per mole, and then I will write my number of moles from each one that I will get actually. So basically, we got 0.038 on the calculator and 0.525, and I need to write here now moles of each one of them, and I need to write over here that this is N of O2, that is actual, very important to label, and this is N of H2, that is actual. How do I know? Because it's written underneath it. I was carrying out all of these steps underneath the element or the reactant that I wanted. So just to guide your eyes. So step number 2 is done, where we calculated the actual moles. Step number 3, pick 1 mole value for each reactant, and then we're going to use it to find the mole value for the other one that is theoretical from the mole ratio. So we are going to pick one. Which one are we going to pick? For example, if we pick this one, okay, you choose anyone that is actual. And now let's do step number 3 and 4 in order to calculate the theoretical moles. So I have actual moles of each one, but I want to get to the theoretical moles because eventually for the same reactant, I'm going to compare its actual moles to its theoretical moles and see which one is bigger. And based on that, I'll make my judgment. So if I picked, for example, hydrogen, now I'm going to make a mole ratio in order to compare. So the next step would be now oxygen to hydrogen. From the balanced equation, it is 1 to 2. Now, actually, I picked this value, and so that's going to be 0.525. And now whatever I calculate for oxygen here, anything I calculate will always be theoretical. So this is of oxygen theoretical. And now I'm going to calculate that by cross multiplying. This is multiplication, and this way it is division. So multiply and then divide over here. So N theoretical is going to be basically 0.525 moles times 1 divided by 2. And that's where you're going to divide that value that you got earlier by 2, and that is 0.2625. Keep it as it is because you're going to use this value, so no need to round. And this is theoretical of oxygen. So keep reminding yourself which one are you calculating. That's why it's very important to organize your work. So always add labels. So this is N of O2 theoretical. Then make a comparison between the actual and the theoretical. So I'm going to use now another color here just to highlight. So my theoretical oxygen moles are over here, and my actual moles of oxygen are over here. So you highlight for yourself and make your comparison. Okay, so we're going to compare these two values. Which one is bigger, the actual or the theoretical? It seems like the actual is bigger because this value is bigger than this value. Therefore, if the moles theoretical are bigger than the actual, so if the moles theoretical for us here was greater than the moles actual, then the reagent is limiting. So therefore, because so the 0.26 is greater than 0.038, and therefore this is actual, and this is theoretical for oxygen, N of O2. Therefore, this means that it is limiting. And so that's all you need to show. Okay? You just proved it. Now, let's do it for another example here. In this example, they actually don't give you the mass. They give you the moles, which is much easier. So your 50 zinc reacts with copper 2 sulfate solution. It's a solid with a solution, and then it makes zinc sulfate and copper solid. They gave you the volume, and then they told you what the moles are. And then also of copper 2 sulfate, and then you have 3 grams of zinc. Show that zinc is in excess. So this one is in excess. Number 1, write your balanced equation. Number 2, convert the actual masses of both into actual moles. So you're going to write here for zinc, and then you're going to write here for CuSO4. In the question, we were given that the actual moles are 0.025 moles. So that is N actual, and it's already been defined for us. Now, for zinc, we have to calculate it. So basically, and they gave you the AR, so the relative atomic mass. So basically, it's 3 grams divided by the MR of zinc, which is 65 grams per mole. And then whatever value you are calculating here, it's going to be N actual of zinc. Okay, so that value, now you are going to calculate it. And so it's 0.0461, and we're going to write here moles, and it's all actual for zinc. Okay, now I already have my actual moles for copper here. Pick 1 mole value. Which one do you want to pick? You can pick, for example, CuSO4, because it's already been calculated, so there is no error in it. That would be a good thing to do. Smart. So then now we're going to do a comparison between why, because we're going to calculate the theoretical moles of the other one. Now we have actual, we need theoretical of something else. So if I have zinc reacting with CuSO4 in the ratio of 1:1 from the balanced equation, because this is 1 and this is 1. If I actually have 0.025 of CuSO4, how many moles of zinc would I theoretically have? Anything I calculate is theoretical, and it's of zinc because it's underneath it. So I'm just going to write Zn here. And then that is equal to same value, 0.025 moles. However, I'm just going to have to remember that it's a theoretical value and it is of zinc. Now, we want to make our comparison between the actual and the theoretical. So now this is my theoretical value. This is my actual value. How do they compare? Which one is bigger? So the actual is 0.04 and the theoretical is 0.02. So it seems like N actual is bigger than the N theoretical because this is 0.0461 and that's 0.025, which means we go over here if actual is greater than theoretical. So I have more than I need because theoretically, this is the amount that I want by calculation. So then it is in excess. So I have proved now that this means therefore, zinc is in excess, meaning it's in excess. So just by showing that. Okay, so it's it's all here again done for you in steps. You can pause the video and redo these questions on your own. Here's another one you can try. So 4.8 moles of calcium is mixed with 2 moles of nitrogen. Which one is the limiting reagent? You can follow these steps again on your own and figure out whether it's nitrogen or is it calcium. So in questions like that, we're always focused on the reactants and just test your understanding over here. Thank you, and that's the end of this part.